Hello, class. We're going to start off with this problem of solving absolute value inequalities or equations. I'm going to start by subtracting 4. I got negative 3 times the quantity absolute value m plus 2. And negative 14 minus 4 is negative 18. Now, at this point, you could say we have an absolute value equal to negative 18. But remember what I said, we got to get everything out before we make that judgment call. And we don't want to distribute this because that's a negative number. We would change the problem. So I'd get absolute value of m plus 2 is equal to 6. Okay. And then now we're in good hands. M plus 2 equals 6. M plus 2 equals negative 6. And when we subtract 2, we get 4. And we get negative 8. All right. So that Freudian slip earlier leads us to say, hey, what are we doing? We're going to be doing inequalities today. So let's review some compound inequalities. Here's an or. We're going to divide by 2. We got x is greater than 8. Or, and this we'll just divide by 4. We got x is greater than or equal to negative 2. Now, they're both greater than. So this is actually an interesting one because we got a negative 2, we got an 8, and they're both shading to the right. Okay. Well, since it's an or, we can include both. I mean, 8 we can put our open circle on, and then 2 we can put our closed circle on. But because it's an or, 8 still ends up becoming a solution to the problem. So that's our graph. And then we subtract 1. We got negative 6x is greater than negative 6. And then we divide by negative 6. We got x is less than 1. Subtract 4. We got 3x is greater than or equal to negative 3. Divide by 3. X is greater than or equal to negative 3. So let's plot that off. We got negative 3 with the closed circle with the point, and 1 with an open point. And we're less than and greater than. This is a textbook we shade in between problem. All right. So how do we take care of absolute value inequalities? Well, here's a very basic one. We're going to split this off in the way we would an equation. We've got x is less than 5. But remember, we need to make that 5 a negative for our second one, which means anytime we're dealing with changing the sign, we're flipping the inequality sign. So, and this is an and. Anytime you start off with a less than in your absolute value inequality, it's an and compound inequality. And that's the main goal for today. We're going to take absolute value inequalities and we turn them into compound inequalities. So when we graph this, we got 5 with an open circle. We got negative 5 with an open circle. And we shade in between. Now, this leads me to a couple points. One, again, when we're less than on the original inequality, it's an and. Okay. Now, notice a couple things. That would mean that these 2 points would always have to be the same. And by the same, I mean they're either both open circle or closed circles. And the extra scenarios we covered when we did compound inequalities no longer apply. If you have an and, it's an automatic shade in between. If you had an or, it's an automatic shade on the outsides. All right, so let's try this one. This is a greater than. So if less than was and, then that would mean greater than is or. So we do x is greater than or equal to 3, or x is less than or equal to negative 3. And since it's or, We got 3 with the solid points. We got -3 with the solid point. And again, because it's or, we're going to automatically shade on the outside. All right, so let's do a little bit more. Let's solve and graph these. So absolute value of x minus 1, we're going to split those up. That's x minus 1 is less than 2, and x minus 1 is greater than -2. And no, I mean, we've been solving equations and inequalities for a while. Nothing changes. We're just learning how to deal with little nuances that new problems bring to us. So this is x is less than 3, and this is x is greater than -1. And since it's an and, -1, 3, open circle, and we shade in between. Again, the in-between outside shading becomes automatic because we're dealing with absolute values. If we were dealing with any other kind of compound inequalities, we do want to be aware of those extra scenarios. So let's go ahead and do this one. This would be x minus 1 is greater than 2, or x minus 1 is less than -2. And then once again, we'll add 1. We got x is greater than 3, and we got x is less than -1. -1, 3, and because we're dealing with or, we're shading on the outside. Go ahead and give these ones a shot. Okay, so let's go ahead and deal with it. It's 8x is greater than or equal to 24, or 8x is less than or equal to -24. All right, we got x is greater than or equal to 3, and then we've got x is less than or equal to -3. And we're in or, so again, we're shading on the outside. -3 and 3, and these are solid points. And again, as I mentioned previously, we're shading on the outside. All right, now the other one ends up being an and, so we do 2x plus 4 is less than or equal to 5, and 2x plus 4 is greater than or equal to -5. So go ahead and subtract 4. We get 2x is less than or equal to 1. Divide by 2. We get x is less than or equal to 1/2, or you could say 0.5 if you wanted. And then we're going to subtract 4 here. We got a 2x greater than or equal to -9. And then when we divide by 2, we're going to get another fraction. We get x is greater than or equal to -9/2. So we got 1/2. Actually, 1/2 is the greater one. And -9/2. There we go. Both closed circles. And we're shading in between. So let's talk about a word problem really quickly. We have a company makes boxes of crackers that should weigh 213 kilograms. Quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 kilograms is sent back. What is the range of allowable value? So how do we set up an absolute value inequality when it pertains to a word problem? Well, we have our x, and then we always want to subtract 213, and we subtract the weight, because what x will represent is a weight of a random box that's selected. So we take that random box, we compare it to 213, and then we take the absolute value. Well, it shouldn't differ any box that varies by more than 5 grams. But when it says more than, we don't want it to be more than 5 then. So we're going to go less than or equal to 5. You could do more than 5 and still solve the problem just fine, but I want to stick to what the company wants. And so then we'll split this off. X minus 213 is less than or equal to 5. And then X minus 213 is greater than or equal to negative 5. We'll add 213. And this first one, we get 218. So it has to be less than 218, or equal to, I should say. And then negative 5 plus 213 is 208. And it doesn't say to graph it, but let's go ahead and graph it so we can get an idea of what these ranges would look like. This would be 208 with the solid point. This would be 218 with the solid point. And then we'd shade in between. So this is the range of acceptable values. So 208, 209. We'll just leave it. That's fine. 209, 210, 211, all the way up to 218. If we get 219 or 207, it's no good. Okay. So now go ahead and give this one a try. A food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. The allowable difference from the ideal weight is at most 0.05 ounces. Write and solve an absolute value inequality to find the range of possible values. So again, we want what the box weighs to be our difference from X, and then we'll put the absolute value around it. And again, they don't want it to be more than 0.05, so we'll go ahead and make it a less than or equal to. And then we make it a compound inequality with an and. X minus 32 is greater than or equal to negative 0.05. We add 32. X is less than or equal to 32.05. So they're really strict about their restrictions at this company. And then add 32. That'll be X is greater than or equal to 31.95. So a very small range in which to work with. Go ahead and try the exit ticket. Thanks for watching.